Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals involving greatest integer function, right? So here we have this problem, that is we have to solve this integral from 0 to square root of 2, and here we have x plus x raised to greatest integer of x, right? So here this symbol denotes the greatest integer function, right? So let us call this integral as I, right? So viewers, whenever we have to evaluate integrals involving greatest integer function, what we have to do, we usually make use of the definition of greatest integer function, right? So whenever we come across with greatest integer function, we have to keep one thing in our mind, that is we have to split the integral, or in other words we can say that we have to search for integers, right? So we'll here first take the limits, that is the lower limit is 0 and the upper limit is square root of 2, right? So here if it represent these two limits on the number line, then we see that here we have x is equal to 0, right? And suppose here we take 1, x is equal to 1, and here we take x is equal to 2, right? And the approximate value of square root of 2 is equal to 1.41, right? So obviously the value of square root of 2, it lies between 1 and 2, right? So square root of 2, it lies somewhere here, so this is square root of 2, and the limits of integration are from 0 to square root of 2. So what we will do, will split this integral, right? So between 0 and square root of 2, we have the integer x is equal to 1, right? So whenever we come across with the greatest integer function, we search for the integers, and for the integer points we break the limit. So here I can be rewritten as I1 plus I2, and I1 is from 0 to 1, 0 to 1, and I2 is from 1 to square root of 2, right? So 1 to square root of 2, and here we can write the integrand, that is x plus x raised to greatest integer of x. Here we have dx, and here we have x plus x raised to greatest integer of x, and here we have dx, right? Okay, so now let us first consider this one. Now see here, the limits of integration goes from 0 to 1. So when x lies between 0 and 1, then by the definition of greatest integer function, the value of greatest integer of x should be equal to 0, right? Because the limits are from 0 to 1. So x lie between 0 and 1. So whatever be the value of x here, which lies between 0 and 1, the value of greatest integer of x must be equal to 0, right? And similarly here, see the limits of integration varies from 1 to square root of 2, which can be written like this, that is x lies between 1 and the approximate value of square root of 2 is 1.41, right? So whenever x lies between 1 and 1.414, by the definition of greatest integer function, the value of greatest integer of x should be equal to 1, right? So here we'll take 0, and here we'll take 1, right? So now we can write this these two integrals as this is 0 to 1, and here we have x plus x raised to 0, and here we have x raised to 0, and then here we have 1 to square root of 2, and here we have x plus x raised to 1, right? Okay, so now we can simplify these two integrals. So we have 0 to 1, here we have x plus 1, because x raised to 0 is equal to 1, and here we have 1 to square root of 2, and this is x plus x, that is 2x dx. And now we can simply integrate. So we have here x square over 2, and the integral of 1 dx is simply x. Limits are from 0 to 1, and here we have 2x square over 2, and limits are from 1 to square root of 2, right? So now here we can cancel these 2's, and now we have I is equal to, first we'll take this one, so we'll take 1 here. So 1 square over 2 plus 1, and minus, when we take 0, both the terms will become 0 here, and here we are left with only x square. So when we take x is equal to square root of 2, this is root 2 square, and minus 1 square, right? So this is 1 over 2 plus half, 1, that is half plus 1 is 3 over 2, and here we have 2 minus 1, so this is 3 over 2 plus 1, and that is 3 plus 2 over 2, that is 5 over 2, right? So the value of this integral is 5 over 2.